This is practice exam 4, question number 1. Consider the sulfur dioxide molecule, which Lewis structure below obeys the octet rule for every atom in the structure and uses the proper number of valence electrons. First, let's find out the total number of valence electrons for the molecule. So we know both sulfur and oxygen are in group 6A. Group 6A, 16 also means 6A. So therefore, number of valence electrons should be 6 for each of the elements. So knowing that, we should be able to calculate 6. So there's a 1 S, that's the S, plus 2 oxygen, each oxygen 6, and that should give us 18 valence electrons. Now let's examine the 5 different structures. See if they use the number of valence electrons properly. Okay, so A. Okay, remember each line here represents 2 bonding electrons. Okay, so therefore for oxygen we have 1, 2, 3, 4 pairs, 2 lone pair and 2 bonding pairs. Total that's actually 8 so far. All right, so that's 8. So let me write that down. That's 8 electrons. Okay, and now here on this side, that's 1, 2, 3, 4. That's another 4 pairs. All right, that's also 8. Okay, so because each line here for the bonding electrons, that's each line represents 2 bonding electrons. So 2, 4, 6, 8. That's another 8 electrons. Okay, since those bonding electrons already counted, they are already counted. So therefore, the total number of electrons for A, that's 16 electrons. So that's improper use of the number of electrons. So this is not even the correct structure for sulfur dioxide. Okay, so let's take a look at number 2, B. So B we have, I'm counting the pairs for both non-bonding and bonding electrons. That's 1, 2, 3, 4. Okay, so therefore that would be 8. For sulfur, we just count these 2. And then for oxygen, we'll count that's 1, 2, 3, 4. That's another 8. So altogether, you add them up, that's 18 electrons. All right, so that's 18. And that's correct. So yeah, structure B does meet this description. So which means the use of valence electrons is proper. Okay, so now let's look at C. C, you can use my technique. You can count. Actually, that's a total of 20 electrons. Okay, make sure you do that. And then that one is out. It is not the correct Lewis structure for the molecule. And D, again, that's only 16 electrons. So, okay, 116, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs, both bonding and non-bonding. So then that's 16 electrons. That one is also incorrect structure for the molecule. Now, oxygen, let's count right here. That's 8. That's another 8. That's 16. And then plus this lone pair, that's 18. So therefore, among the 5 structures, actually only 2 are correct ones. And those 2 are resonance structures. We are still not done yet. So which one actually is the most favorable one? Okay, so we just need to concentrate on structure B and E, find out their valence electrons. No, actually, in order to do that, we need to find out the formal charges, okay? So in order to determine which of the 2 is the favorite resonance structure, we need to calculate the formal charges of each of the atoms in each of the structures. Formal charge equals valence electrons subtracted by non-bonding electrons, which means lone pair electrons, and subtracted by 1/2 of the bonding electrons. Bonding electrons means, of course, the ones found in a single bond, double bond, or triple bond. Okay, so you have to remember this equation in order to get this kind of job done. Now let's work on structure B. Okay, so the formal charge of sulfur, number of valence electrons, 6, and then non-bonding electron, just 1 pair, that's 2. Bonding electrons, 1, 2, 3 pairs, that's 6. So therefore, it's positive 1, okay? Then the oxygen, the 2 oxygens, we have to calculate them separately because they don't have the same Lewis structure. So the one on the left, the oxygen. So again, valence electron, that should be 6, okay, right here. And then, so we're talking about the one on the left. Non-bonding electrons, that's 4. Bonding electrons, that's also 4, but times 1/2. Then that should give us 0. So therefore, this one, if I apply the formal charges here, that's positive 1 for the sulfur, 0 for the one on the left. Then you do the same for the one on the right. That's actually is negative 1. Okay, so then we can do the same analysis with a structure E. Okay, for sulfur, we should have 6, that's the valence electrons, minus 2, the lone pair electron, minus 1/2 of the bonding electrons. So that should be 4. And what would that yield? That actually gives us positive 2. The 2 oxygen, they are identical. So therefore, we can just do, each will have 6 valence electrons. Then they have also 6 non-bonding electrons and 1 pair of bonding electron. And what does that say? That says positive 1. So now positive 2, positive 1, positive 1. Yeah, let me make a corrections. So Actually, there should not be positive 1, should be a negative 1. That's a simple calculation error right there. So, and of course, that will be negative 1, negative 1. So now, according to the rules, using a formal charges to determine the favorite structure. So the lower formal charge, the more favorable. Okay, so you see B, you have positive 1, negative 1. But for E, you have positive 2, you see. So that's higher than in structure B. Therefore, B should be the choice, the correct answer for this question.